Yep.
We need one more.
Oh, for the short tube? All right. Now. Okay, now first, let me explain. Matrices used to not be that big a deal in my day. They're a much bigger deal now because computers, basically. But matrices, I know they're all this crazy wackiness, but they are a huge way of organizing huge amounts of data. For example, if I wanted to, in fact, I did for my master's, I made a program that was meant to predict how a student would do in college. Okay. So what are some variables that might predict how a student does in college?
If they're alive.
Their what?
High school.
Their GPA in high school. Okay, what else?
Their witness.
Their SAT scores, the standardized test scores. Okay, their ACT scores if you had it. The application. What about like a
Teacher recommendation.
So it would have to be quantifiable. So you would have to put a number to it.
Study time.
Study time, okay, that's true. What about their socioeconomic status?
What is that?
Money you got.
A rich person, does a rich person do better in college?
No. Not
Yes,
necessarily.
they absolutely. Okay. It's back in fridge. Generally speaking, yes, rich people do better in school than poor people. That doesn't mean they're smarter, it just means they do better. Okay. It doesn't mean. You need to understand this is a predictive method. It's not guaranteed to happen any more than a person with a high GPA in high school will do well in college. But you could collect something like 8 different variables, and you would have thousands, hopefully, of students and a number for each of those. Now, at that point, once you've collected the numbers, then I don't really care about Jim's name or the GPA title. All I care about is the data. And that's where matrices come in. What you can do with all that data, that's a matrix. And you could have lots of things that you could do with that. You could weight this. You might think GPA is more important as a predictor or as a better predictor than the SAT, and so you'd give it more weight. So you could do that in a matrix. My point, though, is the matrices, I know it feels like, because we're not doing applications much now, it feels like, whatever, I just do this with the numbers and this with the numbers, and it's meaningless. It's not meaningless. It's very useful. And if I have time, we'll get some applications in, but stick with me, and it is good stuff for me. All right? So, review. Matrices on a 2x2. When you see these straight lines, you're finding a determinant of a matrix, and it comes in handy for a lot of ways, especially in Cramer's rule. But how do you solve a 2x2?
A times equals.
Down to the right minus up to the left. So AD minus BC, yeah? Okay, true. And because you don't know those, then that's pretty much all you can do then, yeah?
Yeah.
All right. With that said, then, in number 2, there is an equation. There's a little more to do. What would I do? X plus 4 times x plus 2 equals negative 12. And we could then continue on. X squared, what is that FOILed out?
6x
Squared plus 6x plus 8 minus 15 plus 12 equals 0, right? We're going to get everything on one side. So x squared plus 6x, what? Plus 5. Factors into x plus 1, x plus 5. So x is negative 1 and negative 5. Okay, now all that was review. You've done those before, yes?
Yes.
All right. So today, you're going to talk a matrix of a 3x3, which I believe is new. This is a 3x3 matrix. Okay, there is a lot of room for error here. It is not high concept, it is high arithmetic. You make, let's see, you get 6, 9, you make something like 18, 20 different calculations here, and if you miss one, you miss the whole problem. Okay, so in doing this, you still go down to the right and up to the left, subtracted, but it's a little more. So the first thing you're going to do is recopy the first 2 columns out here. 1, 0, 5, and 2, 4, negative 2. With me? Okay, so the first two columns I'm going to recopy. Then you're going to multiply down to the right 3 times. Here's what I mean. You're going to go 1, 2, 3. Okay, so when we multiply down to the right, we go 1 times 4 times 3, and then 2 times negative 1 times 5, and then 3 times 0 times negative 2. You with me? And you're going to add all those together to get one big down to the right. So, what's that? Oh, thank you. Good call. Thank you. Okay, so what is 1 times 4 times 3? 12. 12 plus 10 or minus 10? Minus 10 and plus 0, yeah? So the total of down to the right is? 2. Are you with me so far? Okay. Now we're gonna. I don't think I have any more colors for highlighting, do I?
You can do the creative thing. You do
Let's just go. 1, 2, 3. Sorry, it is pretty cool looking. All right, so we're gonna subtract the upper right or up to the right products. So what's the first up to the right? 5, 4, negative 3. Then the next up to the right.
1, negative 1,
Negative 1, negative 2, negative 1, 1, yeah? And then 3, 0, 2, yeah? Now, when we do this next time, maybe we can shorten it up a little. Instead of showing all these products, we'll make each little calculation, but we'll do that next. Right? I wanted your notes to be complete as far as communicating what to do. So, what's 5 times 4 times negative 3?
negative 60.
Negative 60. What's negative 2 times negative 1 times 1?
Negative 2. Plus 2.
Positive 2. And what's 3 times 0 times 2?
0.
0. So the total of the subtracted up to the rights is?
Well, negative 60.
Negative 60 plus 2 is negative 58. So 2 minus negative 58 is?
60.
60. Right. All right, that is the determinant of a 3 by 3. This is one way to do it, cofactors, and another way. We'll talk about that later. You with me? Okay. Now then, let's do this in Kramer's rule. So, we're going to maybe shorten up the process a little. Now that you got one good example, we'll make it a little quicker. So, in Kramer's,
I always forget where to put X's and Y's.
all right, so that's why those boxes are up there. So the denominator, what's the denominator make?
It's the X, Y, and Z.
It's the X, Y, Z's, no constants in it. It's just 2, 3, 2, 1, 1, negative 1, and 2, negative 1, 2.
So where are you getting these?
Okay, so these are all the X, Y, Z coefficients. You do not use the constants, 7, negative 2, and 16. So I'm basically just coming from 2, x3 is, those are the x coefficients.
There's a 1 coefficient to X. I think it's 2, 1, 3.
Oh, sorry.
I was stuff.
Sorry, actually, you're right. Thank you.
2, 1, 3.
2, 1, 3.
You got it.
Bad. Thanks. Is that better?
Yes.
Okay, so you were not confused. I just. Okay. All right. So, what about then the numerator?
7, negative 2, 16.
So 7, negative 2, 16 goes in there, and everything else is the same. 2, negative 1, 2. Really cool. Okay then. So in evaluating, let's write our extra two columns. 7, -2, 16, and 1, 1, -1. Is that clear what I'm doing there, where I'm getting?
Yes.
Okay. So now we're going to do this a little more mental work. So 7, 1, 2, what is that? 14 plus 1, -1, 16. So -16 and 2, -2, -1. Plus 4. Do we agree with the total positive down to the righters? Okay. Minus the up to the righters. 16, 1, 2. 32. -1, -1, 7. Plus 7. And 2, -2, 1. -4. Overall then, what's 14 plus 4 minus 16? 2, right? Minus, what's 32 plus 7 minus 4? 35, and 2 minus 35 is -33, eh? The numerator is better.
Can you just keep, once you find out one denominator, can you just?
Yes, we will not redo the denominators once we got the denominator. That's true. Okay, so let's try the denominator.
He's just skipping a step.
U,
He just skipped
sorry, question. I didn't write the products anymore because it just takes too much room if you actually do that in homework. All right, try the bottom and let's see if we all agree. So I got 4 minus 3 minus 2 minus 6 plus 2 plus 2. And that's -1 minus 10, and therefore -11. And therefore x is 3. So 3, 1, 2, so that one's -1, -1, 2. Okay? All right, are we cool on x? All right, y will be less work, half as much work in fact. Y will be a matrix, but in the bottom will just be -11. Right? The y, the denominator does not change for all three of them. What does change is the numerator. What column gets replaced now? The y column. So the first row is back to 2, 1, 3. Now the second column is 7, -2, 16, and the z column is still 2, -1, 2. Copy the two first columns, 2, 1, 3, 7, -2, 16, and start the determinants. You with me? Okay. That's great. Good encouragement. Who said that? Way to go, Leah.
Thank you.
Encourage people.
Wow, I can't brain right now.
You can see how many places there are to make a mistake, yeah? Not that it's hard to do.
Really gracious. All you need is when you're grading.
Well, that's why it's important to
Yes, me too.
show your work. show your work.
Answer negative 3.
So I got 33 in the top,
Yes, sir.
and therefore negative 3 for what?
Yes, sir.
Do we agree?
I think we can skip C and don't change
No,
it.
I feel like we need the
Wait,
practice.
no, wait, Mr. Rickman, please don't change it.
We can solve for Z.
Okay, so absolutely. You could actually solve for Z. You could solve for Z two ways mathematically. You could say, I can, now that I know X and Y, I can put them in and solve for Z.
Yes.
Or you could do the matrix practice.
I mean, I would submit, yeah. But it's much faster.
I guess that would be the work smarter case, but if you wanted to get good practice.
But C is 2. C is 2.
Okay?
For Y, you're supposed to go.
Are we? What is the 7, 8, 2, 1. I'm going to do it real quick because I'm not a sissy. Oh, I'm going to do the easy way. Wimpy kid. So, what do we got there? 32. Minus 6. Minus 7. 21. Plus 4. Plus 16. Oh, this is not looking good. 13. I'm getting a 19 here.
I think you messed up.
Oh, maybe it's okay. 19 minus. What do we got there? 25, 41. Oops.
What?
25, 41. That's not good. That's 23, yeah? 22? Oh, yeah, no, that's okay. Okay, so negative 22 over negative 11 is 2. So the ordered triple where they intersect?
3.
Negative 3, 2. Okay, cool.
Those are not very fun.
These are 3 lines and 3 space.
Oh my gosh, there's another one.
Okay,
I can't do the next one because I have no
this one will not take a lot of work, not nearly as much, okay? So this one's a working backwards. I am telling you this is a setup for Kramer's rule in a system. What I want you to tell me is, what is the system of equations? What was the original system of equations? What was the problem to begin?
I don't even know. Wait, isn't it
You
just...
can, okay? So what does the denominator tell you? This tells you the
All of the little thingies.
the coefficients. They're called in math, not little thingies. Okay? They're the coefficients of the variables. So the coefficients of x are
2, 1, 4.
2, 1, and 4. The coefficients of y are
negative 3, 1.
negative 3, 1, and negative 5. And the coefficients of z are
1, 0, negative 8.
1, 0, negative 8. Yeah? Okay. Now, surely we need the constants. How do we find the constants?
It's the middle one.
The middle one. Why is it the middle one?
Because it's Y.
Yeah, these must be the constants. So they must be the case 6, negative 4, negative 42. That must have been the original problem. Do you agree? Okay. All right. For a stamp, rather than a closure on some paper, would you do number 8 on the problem set?
Yes.
You will have lots of room in the box to work as you.
I'm glad that this was a lesson today because I can actually do what you do. Yes.
Okay, so you're doing number 8 on page 576.
579.
579?
Mr. Rickman,
Yes.
what's the test going credit?
It's a great question. It is through
Okay,
99, I believe. 100 wasn't a lesson, so I believe it's through 99. Yes.
Really, really quick.
Yes.
I figured out.
Yes. Oh, no, it says solve for Z.
Aw,
Sorry, read carefully. It says only solve for Z, right?
so you've been blind for 3 weeks. So you've been driving unsafe 3 weeks.
Make sure you look for placeholders. You see how there's no X's, for example, in the second row? Be careful.
Do you put 0 then?
Yes.
So musician, no, musician.
My question. I forgot how to figure out the
Hi.
Hi.
Did you get?
No. For 8?
Oh, man, I'm doing it.
How did you not?
What'd you get for the numerator?
For the numerator? -5.
What'd you get?
No.
No.
I got all the zeros. Well, this one.
So 2, 0,
0,
1,
15. No.
3, 1, 2.
Wait, it's 302. It's 201 312. It's not 312. It's 302. It's 5. Yeah, I got 5.
Maybe 1, 2?
Yeah. We gotta put a 0 there. That's what.
Oh, I
So
so what did, so you didn't,
I got.
did you get 13 plus 22?
I forgot. I think I did it wrong. Yeah, it's plus 0.
Oh,
Wait, down? Yeah, it's plus 0. Oh, sorry, hold on. 0, -13. How did we make this exact same thing? So then you got -9.
Yeah, that's what I got. I got Z equals 3.
dang it, I didn't get 3. What'd you get in the numerator?
The numerator, -9, and then the denominator was
Wouldn't
-4.
this be a 1?
No, there's no X.
Oh, okay, never mind. Did you get -3 on the bottom? I just got
Yeah.
25 in the bottom.
I got -3 as well.
0,
Because there's a lot of zeros.
0 plus
0.
6,
0.
0. What did I get?
It's 1 plus 8 plus 3. Yeah.
What did I get? Oh,
That's what I don't
these are.
It's 3.
That's an issue. That's a 0.
That sounds bad for you.
And that's,
How'd you get?
1.
No.
The zeros are what I was getting at. Forget about them. I just kind of skip over this.
Yeah. Okay, cool. Thank you.
Thank you.
I also just corrected it. Wait, all your finished?
Okay, thank you.
You're not getting to about math.
Thank you.
These are worth, yeah, honestly.
So this here, so this third down, 202. What is it?
Oh, 0.
There you go. So second one. So that should be 13. There you go.
Was the answer 3?
Is that right?
Yes.
Oh, 5, 6.
Oh, no.
So am I correct on the right track now?
I hope so. No.
This also uses the
That's a
same.
0.
This is
Oh, I forgot to change
so
that
this is
stuff.
13.
No.
Oh, you did do beach days.
Did you get negative?
So 13 minus 5
Yeah.
2 is
It's positive.
I woke up so
Hey, welcome. Hello. Uh-oh. Go back to Z, dude.
I found X equals 1, and then I found Z at the
And
end.
how do I know if X is 1?
Because I solved for it.
And how do I know? I didn't have to do X, so I can't check yours. Thank you. Hi.
Hi.
What the heck did I do? Oh, this should be-
Yeah.
I can't do this.
Thank you.
Cool, thank you. Hi. See, that's all. Hello.
Can't do that. Someone was like, what is 7 times 6? I'm like, 43. Classic.
And then afterwards, set up the
Not the top one. I messed up on the top one.
Thank you.
Oh, you got it. Yeah, you can take it.
Can you look at number 2?
Sure.
I wanted.
Carrie randomly selected pot. Then drew one corner. What is the probability that one is going? So each pot has the same chance of being selected.
So it's the probability of, whoa. So is it the probability of a single thing happening, or is it an OR thing?
I was just wondering if I could get yesterday's set and then copies from today's for
Yes. All right, so.
Why are you overthinking?
Sorry, what's it?
Probability of a pot.
Okay,
That's the probability of a pot and a coin.
randomly selected a pot, so that's, and then drew a coin. So, is this probability of or and?
I can't tell. I honestly can't tell.
I think it's
I don't think she can.
and.
These are really
Yeah.
hard for me, guys.
Think of it like this. First thing you'd have to do is choose a pot. Yeah? And then off of each of those pots you'd have so much gold. So it's a branching kind of thing. It's first you choose the pot and then it needs to be gold. So it's and. Treat it as and. Right?
Why are you talking about
Boom. Half of the top. What is your numerator total?
what is
Little
this?
part.
The last
I think it was
So that's the rule. Those four things are the
last
first
part.
thing we're looking at. Thank you. Hi. Do-do-do. This is
Oh, okay.
because otherwise you
Because 6 minus 9 and negative 9 is not positive.
Negative divided by probability. Okay, thank you. All right.
Pretty sure.
Wasn't that fun? You got extra practice. Good job, James. I'm sure you're happy about that.
Actually, gonna live there. Why are we so bad at this? So bad at it.
Did you get that fast one? Or you don't have that?
But it's not there.
So the first thing that has to happen for you to get the gold is you have to choose the one with holders, right?
Yeah.
And what is the probability of you gold plus other stuff? What's the probability of you randomly choosing the pot with gold in it? 1 out of 3.
And the probability of getting the gold is 4 out of 11.
Yes, and then 4 out of 11. And then once you have that pot, then you have to say, all right, what's the probability of that pot choosing gold? That's 4 out of 11. So you multiply. So it's 1 and both things have to happen. It's not or, it's and. It has to be the right pot and the gold coin in there.
Oh, so it's not like the one where you expand it out?
No, it's not. That's not an or case. It's not an or case. Okay? Hi.
Negative.
I do not agree with your denominator.
Did you get negative 0 or are you just
0.
We got it wrong.
So what are these 3 products?
0. Oh gosh.
Plus
I'm so confused.
3, 2, 1. Oh, then no, that's 3, 2, 1.
So it's
Oh, wait, don't you subtract it if
No,
you add it?
zero.
Oh, you always
Multiply. So product.
Oh, okay.
So you have 0, 6, 0.
Oh,
it's 3, 0. Oh, yeah.
Okay, so that's.
And then the next one.
Now let's go
Yeah.
up to the right. Boom.
Which
Boom.
is 3 gives you.
So what's that?
So you get 0 minus 6 plus 2 minus 1 plus 8 is 0.
So minus 9.
Plus 8 plus 0.
So bad at math.
Minus 9.
I keep forgetting how to zero.
That's
No, wait.
I know I keep doing it. I keep putting it as 1.
6,
Okay.
0.
okay.
I keep thinking it's 0.
1,
Hi.
8, 0.
You want photos up here?
Okay, I'm gonna go see.
Right.
I feel like it is.
Oh, and then
Yeah. I think it is. Miss Smith let us do that.
Really?
Yeah.
She didn't make you total the downs to the rights and the ups to the rights? It's like that's
I did it completely wrong.
I don't like it.
I don't get stamp.
I don't like it. Your denominator is good, but your numerator is incorrect.
how did you say it?
What part of it is incorrect?
Your numerator is not negative 11. Your numerator is something else. So find your numerator instead. What?
numerator is negative 9.
Can we use the
I've never
calculator on
seen
the
this
line?
one.
This is 256 times
Oh.
3/4.
Yeah.
That's quite excessive.
I can do math.
Just do a little multiplication on the
I
side.
don't feel like that's necessary.
What? I think it is.
No,
Certainly.
it's not.
256 times 3 over 4.
Yeah, 256.
I'm rich.
I don't feel like that's different.
I do.
It's not. How many times does 4 go to 256?
Oh. Yeah, we know. You're just kidding. It's easy.
So, trouble. Alright. How we doing, people? Oh, it's time to go. Alright. Have a great day. If you're not done with that, come see me. What the heck? How come you don't have a stamp yet? What are you doing? Are you confused? If you're confused, come see me.